Hello, my name is Vineet, and I will be going over the methods and results section of this presentation. As mentioned before, we will be using the Zebra model to analyze the data, but before that we have to clean it up, and to do that I used ICA to split apart and reform the dataset to remove all the noise. Afterwards, we used the Zebra model to generate low-dimensional embeddings of the data, and as you can see on the side, this is the embedding space for the model. We then applied a gradient boosting classifier to classify the latent space, and just to test it out and see how it works, we also applied a k-nearest neighbors clustering algorithm to verify the results. The results were not great. As you can see here, there's just a lot of overfitting, and the actual accuracy just wasn't that good. When looking at the actual latent space, we noticed that there were two very distinct sections. There's the symmetrical tasks, so left non-sim and right sim, and the everything else, which were all the facial recognition tasks. It seemed that everything else seemed to have a very similar EEG response, and Zebra was unable to really get much from those. So to see if we can get better results, we tried binary classification between those two labels and everything else. As you can see here, the results were a lot better, showing that there was in fact a good correlation between, there was two distinct clusters. And so to see maybe those two that cluster was overshadowing everything else, making Zebra not able to see the bulk of the smaller differences, we tried to remove those, and we got very bad results. We have one likely explanation for this, was the fact that the model is receiving a lot more training data from the wrong places. As you can see here, even though the largest signal comes from the temporal lobe, the majority of electrodes center around the parietal area of the brain. Specifically the postcentral gyrus, where a lot of facial recognition tasks are handled. And as you can see, so what's happening is that Zebra is getting a lot more information from the wrong places, where it's not really thinking that the temporal lobe information is important, despite it actually being pretty important. So we tried filtering everything except for the temporal lobe electrodes, and we also got similar results to our initial multi-class classification attempt. And we think this is just because the model had too little data to train on, because it went from 74 electrodes for 19 subjects to around 15, which is honestly way too little. That's all for me. Thank you.